Myself D. Kalyan Kumar. I'm pursuing Power Electronics in Gopuraj Ranganathan Institute of Engineering and Technology. My project title is Instantaneous Power Control of StatCom with consideration of power factor correction. My internal guide is Sridev Madam. First of all, I am going to explain something about the StatCom. The StatCom, the main basic principle of the StatCom is whenever the StatCom is connected to the power system, how it works. The StatCom output voltage is less than the power system voltage. In this case, the StatCom will act as a inductive mode of operation. During the inductive mode of operation, it absorbs the reactive power from the power system. And coming to the second case, when power system voltage is less than the StatCom voltage, and it acts as a capacitor mode operation. During the capacitor mode of operation, it delivers the reactive power to the power system and it maintains the voltage stability. Here is my hardware setup. Basically, the StatCom consists of a power circuit. The power circuit is developed by using the 6 IGBTs and the capacitor. For a voltage source converter, the capacitor is the load. The capacitor rating is 1000 microfarad of 63 volts. For the operating of the voltage source converter, we generate pulses to fight the IGBTs. For the generation of the pulses, I use the pulse width modulation technique. In that pulse width modulation technique, I use the sinusoidal pulse width modulation technique. For the generation of the, basically the pulse width modulation technique consists of basically the pulse width modulation consists of comparison of the two waves, that is reference wave and the carrier wave. The carrier wave is the triangular wave and the reference wave is the sinusoidal wave. Basically, the sinusoidal wave is of having 50 Hz frequency and the triangular wave frequency is somewhat high. So here I am using different ICs to generate the triangular wave. This is the IC of TL082. By adding some resistance at the respective terminals of these ICs, I generate the triangular wave. Here is the triangular wave output observed from the CRO. The frequency of the triangular output is based on the varying the value of the capacitance. That is, here I connected the capacitor to one of the terminals of the IC. From the output of the IC, this triangular wave is compared with the sinusoidal wave. The sinusoidal wave is extracted from the function generator, and these two waves are compared with the op-amp IC. From this we generate the 3 pulses. Here we having the 6 IGBTs. For the generation of the another 3 pulses, we use the NAND gate, and that is opposite to the what we generated from previous pulses. And the second method to generate the pulses is by using the Arduino. This is the Arduino UNO kit. In that we generate the triangular wave of some frequency. And this is the program to compare the triangular wave frequency with the sinusoidal wave. And this is the RPS regulated power supply. This regulated power supply is given to the ICs for the external supply. Thank you.